right, so today we're going to look at this problem, and the problem reads, let x, y, and z be real numbers such that y times x minus z plus 1 equals minus 1, x times y minus z minus 1 equals minus 1, and xyz is equal to 1. What is the sum of all possible values of z squared? So the first thing that we can notice is that from the condition x, y, z is equal to 1, we note that x, y, and z are all non-zero, because if any of the variables are equal to 0, then their products cannot be equal to 1. And so now we're going to look at the first two equations. So this is equation 1 and equation 2. So expanding out equation 1, we have xy minus yz, and then plus y is equal to minus 1, which rearranges to xy plus 1 is equal to yz minus y. And expanding now equation 2, we have xy minus xz minus x is equal to minus 1, which simplifies to xy plus 1 is equal to xz plus x. And so now what we can do is we can divide the first equation by y, because we know that y is non-zero. So what we then get is this equation simplifies to dividing by x. We have x plus 1 over y is equal to z minus 1. And we can also divide by x from the second equation, because x is non-zero, and so we get y plus 1 over x is equal to z plus 1. And so now what we can do is we can multiply this equation over here and this equation over here, because we know that there's a 1 over y term here in the first equation, and a y term here, so that can somehow cancel out, and same for the x terms. So if we multiply these two equations, we get xy plus 1 over xy plus 2 is equal to z squared minus 1. And we also have the third equation here, that xyz is equal to 1. So we can plug that into this equation. And so this equation becomes 1 over z plus 2 is equal to z squared minus 1. And so this equation is purely in terms of z. So we can simplify this equation to get z cubed minus z squared minus 3z minus 1 is equal to 0. And so now we have a polynomial, a cubic polynomial in z, and straight away we can notice that z is equal to minus 1 is a root of this cubic, and indeed if you plug in z is equal to minus 1, we have minus 1 cubed minus 1 squared minus 3 times minus 1 is equal to 0. So this checks out. So we know that z equals minus 1 is a root of this cubic, which means we can factor this cubic into a product of z plus 1 as well as a quadratic, which can be found to be z squared minus 2z minus 1. So now we have all possible values of z. We can see that the possible values of z are minus 1 as well as 1 minus root 2 and 1 plus root 2. But now we need to be careful and make sure that these values actually correspond to solutions. So notice that when we plug in z is equal to -1 into the equations, we get from the first equation, we have xy plus 1 is equal to -2y. That's from the first equation. The second equation, we have xy plus 1 is equal to -2x. And the third equation, when you plug in z is equal to -1, we get xy is equal to -1. And so we can plug back in xy is equal to -1 into the first equation. And so equation 1 and equation 3 implies that y is equal to 0. And similarly, equation 2 and equation 3 implies x is equal to 0. And so that implies that x and y are both 0, which we know can't happen because x, y, and z have to be non-zero in order for their product to equal 1. So we know that z cannot be equal to -1. However, we can check that z can equal 1 minus root 2 and 1 plus root 2 by doing a similar process and finding that there is no contradiction to those values of z. And so going back to the problem statement, what is the sum of all possible values of z squared? So the answer is just going to be 1 minus root 2 squared plus 1 plus root 2 squared. And that gives 6 as the final answer.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.